Miles of aging, corroding pipes are deteriorating underneath our streets right now, pushing municipal water systems to the breaking point. Across Sweden, local governments face an impending financial cliff. Between 2022 and 2040, merely replacing obsolete water and sewage systems will require an estimated 560 billion Swedish krona. This chart illustrates the required annual investment calculated by the Swedish Association of Local Authorities, a steady 31 billion krona target. But actual investment sits at 21 billion krona. This 10 billion shortfall compounds, becoming an unmanageable deferred maintenance backlog by 2040. Failing to close this gap guarantees severe operational interruptions. When water and sewage networks fail, the disruptions pose direct threats to public health and local ecosystems. Standard budgetary adjustments are mathematically insufficient to bridge a financial chasm of this magnitude. A 560 billion krona deficit indicates that the current model for funding civil engineering has failed entirely, demanding an immediate structural overhaul. When municipalities attempt to cover these astronomical costs using traditional funding methods, the immediate financial burden falls directly on end users. To match the investment need through utility bills alone, municipal water and sewage fees would need to increase by 6% every single year. That 6% hike is roughly 3 times higher than Sweden's general inflation target. It is an unsustainable year-over-year cost increase for residents. To circumvent the strict statutory limitations capping their capital access, municipalities must merge their resources and form inter-municipal partnerships. Once that capital is pooled, it must be deployed away from traditional infrastructure and into high-efficiency, source-separated sewage architectures. Without combining these two strategies, attempting to force fee hikes will economically penalize the public while leaving the aging grid largely intact. To survive the coming infrastructure cliff, urban planners have to treat municipal finance, legal structures, and civil engineering as a single interdependent system. Swedish local governments are paralyzed by legislative restrictions that prevent them from proactively fixing their infrastructure. Forbidden from pre-funding their own projects, the logical next step is outsourcing the capital requirements to the private sector. Researchers at Uppsala University investigated exactly this scenario, evaluating privatization opportunities for Sweden's water networks. This flowchart maps restricted options. Saving capital for future cycles is blocked by the Water Services Act, or LAV. Forbidden from accumulating reserves, municipalities can only raise funds when massive reinvestments occur, injecting intense volatility into current costs. Returning to the flowchart, full privatization models hit another statutory wall. Swedish law dictates external parties cannot hold the principal role over public health assets. Furthermore, facilities cannot operate purely for profit, dissolving options for private equity. The only legal exception left on the table allows municipalities to utilize highly specific operation and maintenance outsourcing agreements. Even then, these maintenance agreements are tightly restricted and governed by the strict public procurement acts known as LOU and LOUF. The result is a legal deadlock. Municipalities are forbidden from saving capital in advance and strictly barred from transferring liability to private firms. With privatization completely off the table, the only legally compliant pathway to consolidate capital is forming inter-municipal partnerships. Operating independently, smaller municipalities face severe shortages in specialized technical manpower and struggle with low internal organizational capacity. By merging fragmented resources into a single joint municipal company, local governments bypass individual capacity limits. Pooling capital creates a robust structure, dramatically decreasing the vulnerability of any single municipality executing massive projects. Distributing these immense costs across a larger subscriber base effectively normalizes rate levels, smoothing out the financial spikes caused by the Water Services Act. We can see this working in practice with NSVA, a successful joint utility company operating across multiple municipalities in northwestern Skåne. This type of organizational consolidation is the mandatory prerequisite to unlocking the capital needed for advanced engineering. With the financial structure in place, pooled capital can finally be deployed into physical engineering on the ground. The Oceanhamnen residential project in Helsingborg, powered by the nearby Ricolab facility, provides the premier case study for next-generation water infrastructure. This diagram illustrates the flaw of traditional engineering, combined sewage systems. Toilets, sinks, and food waste all dump into a single pipe, diluting waste and making resource extraction incredibly energy inefficient. Ocean Homnin replaces that outdated model with a source-separated architecture known as 3 pipes out. The first line is a blackwater pipe connected to vacuum toilets, keeping the waste stream highly concentrated. The second line is a dedicated graywater pipe, handling the runoff from baths, dishwashers, and laundry. Finally, the third line is a green vacuum tube dedicated to ground food waste. This eliminates the need for heavy garbage truck transports and feeds organic matter directly into the biogas production chain. Because this blackwater is undiluted, it can be routed directly to anaerobic digestion facilities, which maximizes the yield of extracted biogas. The concentration also allows engineers to efficiently extract high-grade phosphorus and nitrogen, creating valuable biofertilizers for the agricultural sector. By segregating this warmer water, localized heat exchangers can immediately recapture its thermal energy and recycle it directly back into the building's heating system. By strictly separating these streams at the source, this architecture mathematically transforms urban wastewater from a costly disposal liability into a high-yield, localized resource. This visualizes the codependent relationship at the heart of modern infrastructure planning. Administrative innovation and physical engineering cannot exist without each other. The system forms a closed loop. Public partnerships secure the necessary capital. That capital builds source-separated systems, which drastically lower long-term operating costs. Sweden's 560 billion krona deficit cannot be solved by punishing citizens with endless fee hikes, nor can municipalities wait for prohibited privatization models to suddenly become legal. The dual pivot of structural consolidation and advanced source separation remains the only viable blueprint for survival. Embracing this integrated approach allows local governments to completely invert the crisis. It turns a compounding financial threat into localized, energy-generating infrastructure built to last the next century.